Welcome back. I am going to solve paper 1-2, May 2024 of the same series of 2024. So today I have already solved the paper because the previous video was so long and I don't think it is worth it. So I'm going to just explain you guys this whole paper. Let's begin. The first question is from chapter number 6, series. In this question, they're asking us to find the positive constant of A. And we have been given a condition. Let me change my color of the pen so it's different for the writing, okay? So they've given us a condition that the coefficient of x squared is 12 times the coefficient of x squared in a different expansion. So first, we are going to just find the coefficient of x squared in both expansions. So you see, we have to find the coefficient of x squared. So instead of expanding this whole thing, it's going to be taking too long time and we do not have that much space. So we're going to just pick one specific term, which is x squared. So we know that the power of x should be square. So this term should have a square on it. And we can tell which power should be used on the second term because the overall power should be 6. So 2 plus 4 is 6. And here we are going to do combination and the overall power combined with any of these two, it doesn't matter. Because we'll get the same answer. So we found the coefficient of x squared in this expansion as well, similarly like above. And we have to find A here. So the condition was that the coefficient of this equation or expansion is 12 times the coefficient of x squared in our expansion of 2 plus ax raised to the power 5. So we put this condition that 12 into 80a squared should be equal to 240. Because we are just talking about coefficients, we are not writing x squares. You can write x squares, but they'll just cancel out. Look, if I write x squared here and x squared here as well, we'll just cancel it out at then. So there's no point in writing it. Then we are solving it, and after solving it, we get a squared is equal to 1 over 4. And after taking the square root, we get a plus minus. So now we have to decide whether a is a positive answer or a negative answer. So it was already given that a is a positive constant. Hence, we are writing a is equal to 1 over 2. Moving to the next question. So this question is from chapter 2, transformation and translations. Most people find it quite difficult because it's a tricky question and it's 5 marks and you just need to find the transformations. So how do we do it? Let me explain it because I have a lot of space here. So we have an equation y is equal to x squared and it is transformed into y is equal to 4 minus, okay, let's just, no, okay, this thing. So now we have to understand what did we do to get this final answer. Okay, so let me tell you one thing. When we are talking about y-axis translations and transformations or stretching and x-axis together, because seeing this equation, I could easily tell it is being stretched, translated in y-axis, x-axis and translated in y-axis. Y-axis, x-axis, and y-axis. Now, how do I know this? Okay, so in y-axis, anything we do, it works on overall. Overall equation is changed, okay, whenever we do on y-axis. But when we do it on x-axis, only x is being affected. So overall equation means the y value is affected, and on the x-axis, x value is affected. It makes sense, okay? So now we have to understand which one we do you do first, or the y-axis, the x-axis. Well, you could do any one, it doesn't matter, because the sequence in y and x-axis does not matter. But when we're talking about only y-axis, then the sequence matter, whether you do stretch first, reflect first, or translate first. So here we use the trick that I have my trick, you can have your own. It is SRT Demon. Well, it's a car, okay, from Dodge. My favorite car, SRT Demon. So S means stretch, R means reflect, T means translate, And the D for the demon means downwards, which means vertical or y-axis. So that just defines all the sequence: stretch, reflect, and then translate downwards. So we do we first. And similarly for the x-axis, the inverse of this: first translate, reflect, and then stretch. This is number 3 for, like, we have to, for the x-axis we go 1, 2, 3. For the y-axis we go 3, 2, 1. I hope it's clear. So let's see the equation. The equation says that we have a translation in the y and x-axis plus a stretching in the y-axis. How do I know it's a y-axis? Because it's being multiplied outside. If it was in the x-axis, it would have been something like 4x. It would have been with x only, not the whole equation. This would mean that it's on the x-axis, but this thing is on the y-axis. Now we can solve it. So what do we do first? I choose that I want to go with the x-axis first. I want to go with the y-axis later, because for x-axis we only have one transformation, which is a translation of -3. When it is -3, the translation factor is +3. Okay, it's +3. You write it 3 because we are translating x by moving it by 3. We write -3 here, but actually we are adding it. Similarly, now we are going to move forward. We have a stretch of 4 because according to the SRT demon, we have to stretch first. So stretching by a factor of 4 in the y-axis, you have to write the axis correctly with the factor that is being worked on, like in translation, in reflection, stretching, whatever. And then we have a translation in the y-axis. We are going to write, if it's -8, we are going to write it as it is. Okay? I hope it's clear. Just for the x-axis, if there's a minus sign, you write the positive factor here. And if it's a if it's a positive sign, we would have written a negative here. Look, actually why it is. Let me explain it to you. Why it is like this. So you see that when we are doing this reflection and translation thing, we actually do that. Y is going to be y -8. And we just write the whole equation here in y. But when we're doing the same thing with x, like x should be equal to, x dash should be equal to x plus 3. So what is our x dash? This minus goes there. This is our x dash. So x dash -3 would replace our original value of x. That's why we write a minus sign. I hope it's clear to you guys why we're writing a minus sign and why we're writing a plus sign. And when do we do it? In the x-axis, because x-axis is a little tricky in translation. Moving forward, we have question 3, which is about trigonometry, my favorite questions, because they're quite easy and understanding. So first of all, we have to show that this expression can be expressed in this form, which is quite simple if you know the formulas. The first formula that we have used in this step is that tan theta is equal to sine theta over cos theta. So replacing tan theta with this means that our cos sine is written here and it's multiplied, so cos square theta plus 12 as it is. Now we are using another formula. Okay, I have skipped a step here. So actually what is it is being done, it's being cross multiplied here, and then actually it's factorized. Like I multiply this whole part with cos square theta here, and similarly on the other side. So that's the reason we have no denominator on this part. Now we have like something like sine theta, 7 sine theta plus 12 cos square theta is equal to 0. But if I see this, it is all in sine, but my answer till now is in cos. So we're going to simplify it further using another formula, which is cos square theta plus sine square theta is equal to 1. These are just a few formulas you have to remember in trigonometry, and then you can easily do these questions. Solving it further, simplification, and we do get the equation as it was. So what did I do here? This is plus, this is minus, and this is plus. So we're just going to multiply the whole equation with a negative 1. That's the reason these plus signs are changing into negative and the negative signs are changing into positive. Part B. We have to solve this equation and find the solution for theta. Quite easy if you know how to do it. So actually, this part is same as the above part, and we just proved that it could be equated to this equation. So we just write the equation. Now everyone knows in chapter 1 of our book, we have learned about how to solve quadratic equations. So this quadratic equation is being solved by factorization and splitting the middle term. So 12 into 12 is 144. And the factors of 144 that are used here, that after subtracting and addition or whatever operation you do between plus and minus, gives us a minus 7 are 16 and 9. So if I subtract 9 from 16, no, if I subtract minus 16 from 9, I do get a minus 7. So that's why we are writing these equations. Now simplification is being done here. Taking 4 sine theta common in the first two terms, these two terms, and left with 3 sine theta minus 4, and taking 3 common in the other part so that we have same terms here and here, and then solving it. I hope everyone knows how to do this step. So now we are equating it. This side equal to 0, then this is equal to 0. Okay, 4 sine theta plus 3 is equal to 0. 3 sine theta minus 4 is equal to 0. Now, let me tell you why this is not possible. So we solve it, we get sine theta is equal to 4 over 3. And if we see that 4 over 3 is equal to 1.33 in decimal. But, we know that the highest value that sine theta can take under any value of our theta is 1. But this value is 1.333, which is greater than 1. That means there is no possible value for our angle to give us this answer. That's why it's not possible. You could do this on the calculator, you'd get math error, but the explanation why it is not possible, I just gave it. So now we have a negative sign here. Negative, negative. Ignoring it, we take the inverse, we get 48.6. We are writing in degrees because they give the range in degrees. Then we know that sine theta is negative in quadrant 3 and quadrant 4, meaning that according to this y-axis and x-axis, add sugar to coffee. This is all positive, only sine, and it's cosecant positive, tan theta cotangent, and cos and secant. Okay, so that means it's negative here, it's negative here, meaning that quadrant 3 and 4. So quadrant 3 and 4, to find an angle in quadrant 3, we add it with 180. So addition with 180, we get 228.6 degrees. Similarly, for quadrant 4, we subtract the angle from 360, we get 311.4. That's the answer. I would advise that you guys, like at the end, don't just leave your answer separately. Put a box around it or write the answer something like this, because it gives the examiner who's checking your exam a good look. So now the next question, to find the inverse expression of f of x is equal to square root of x minus 1. We are given the domain that x is greater than 1. Replacing f of x with y, taking my x as subject, replacing x with f inverse of x and y with x, and that's it. Done. We are done with solving this equation. Now we have a diagram. Okay, this is a diagram. Okay, what are we supposed to do? We have to find the range and the value of g inverse. So the range is the highest value that our y-axis can take for a given graph. So if I see this graph, this point is my highest value because after this, the graph is moving downwards and the graph is moving downwards here. And at this point, my value of x is 0. But just for making sure, I have taken x is 1, minus 1 and x is 1 too, just to make sure. So that means my value for y is 0.5 when x is 0. How did I calculate this? Well, g of x was given. Substitute the value of x as 0 and you'll be just left with 1 over 2. So our g of x is lesser than or equal to 0.5 and our g of x is always greater than 0 because our graph never touches the line of x-axis. So it is always greater than 0, never equal to 0. And why does g inverse not exist? So let me tell you why. For g of inverse to exist, our function should be a 101. But this function is not a 101. Why? Well, you see, let's take this value. Let's say it's something like 0.46 or something. Okay, so let's say this is 0.46. And this is, okay. Let's not take 0.4. Let's take 1 over 3 here. 1 over 3 here. This is negative 1, this is positive 1. Okay, why? So you see, I have the same input value. I have the different input values, minus 1 and positive 1. They are different inputs. But my output is same, 1 over 3. You can see it here as well. If I put x is minus 1, and if x is equal to 1, I get the same output, which means that my function is 1 to many. For one output, I have many inputs. So that's the reason our g inverse does not exist. So how do we write this in words? G inverse does not exist because our function is a one-to-many function. Next question, it has 3 parts, okay? Function h is defined h of x is equal to 1 over x squared plus 2 such that my x is greater than 0. Meaning that now this function is a 101, though it is equal to g of x, but they're saying that it is greater than 0, meaning that we are only considering this part of the graph. This part is ignored, meaning that each value of my input would give me a different output. It is a 101 function now. So now we have to solve the equation. Give your answer in the form of this. Okay. So we have f of x because there's a composite function here. F of x, okay. What is my f? Let me just write it here so that we do not forget what our f was. Where is it equal to? And x is greater than, okay. This is, so f of x. First, let's solve this part. What does this bracket, the inner thing in the bracket means? Well, guys, this is the value of our x that is written inside the bracket because look, we write f of x. And this is the value of x if I replace it with a numerical digit. So substituting it in the equation and solving it, then we get f 25 over 16 as 1 over 4 for the value of y. Now we are going to form the composite function. So we have h f of x, which means that we're going to replace the value of x with the value of fx. Okay, that's our new variable. So h f of x would be something like this. And they have given a condition that this is equal to whatever answer we get for this. That means 1 over 4 is going to be equal to our composite function now that we are creating. Now solving it further, you can see the steps. They're quite simple. Moving to there, we get positive 2, then taking the square root, plus minus 2. Moving 1 there, taking the whole square. X is equal to, the final answer is x is equal to 1 plus minus under root 2 square. Now, we have a plus minus. We solve both of them. With the plus sign, we get x is equal to 3 plus 2 square root 2. With the negative sign, we get 3 minus 2 square root 2. But the answer is going to be only 1. And why is that? Well, you see, at the start, I wrote the domain for f of x. When you create a composite function, whatever value of x you get should be within the domain of our function f of x. So they say that x is greater than 0 and our x should also be greater than 1. It should be both greater than 0 and greater than 1. Our 3 plus 2 square root of 2 is greater than 1 because if I take the decimal value, it says something 5.8 something. And this thing, if it's 3 minus, we get a value that is 0.17 something, okay? And this value is my value that is lesser than 1. So we are going to ignore this value and just write the positive value, 3 plus 2 square root of 2 only. Ignore because the value is lesser than 1. There's a reason given. You have to write it, or you could just simply write the answer only and only the positive one. Okay? If you write this answer, I think you are going to lose marks. Let me just make sure. So guys, I've opened the marking scheme and they have at the last said must discount the solution of this. Meaning that if you write that, I think you're going to lose marks. Moving on to the next question. Let's just keep the marking scheme open at the background. So next question is again series, progressions, sequences. So this question is also using trigonometric functions. Let's solve this. We are given the range in radians. I don't like to work in radians because it's too confusing. But however, let's work. Given that theta is 1 over 4 pi, find the exact sum of 40 terms in an arithmetic progression. Okay. N is equal to 40. Our first term is tan theta. Our second term is sine theta. In arithmetic progression, we know there's a common difference that is same between two terms. Not any two terms, adjacent two terms. So we are going to take sine theta 1 over 4 pi. 1 over 4 pi is actually equal to 1 over 4 pi in degrees is, wait a minute, let me confirm what is 1 over 4 pi in degrees. It's 45 degrees. Okay. So now solving this part, you could just put it in your calculator straightly and solve it. You'll get the value of D. Now we have D. And we do have a formula to find the sum with the arithmetic progression, which is this thing written right over here. We have all the values and A1, D. Just put the values. Solve tan theta again because we also have the value of theta which was given 1 over 4 pi. Substitute it, do the simplification. You'll get your final answer for the sum of 40 terms. And we have to write it in this form because they have given exact answer, not decimals. So we are not supposed to write decimals. We have to give the form of the answer in exact terms using the square root or whatever it was. Part B. Why is there a part B? And why does part B has two parts? Okay. The first term of the geometric progression is tan theta sine. No. Okay. Find the sum of infinity. Infinity and beyond. Let's go. R is equal to, okay, R is a common ratio between geometric terms which is same for any two terms that are adjacent. Sine theta over tan theta. We do not have that. Look, it's written in terms of theta. We do not have the value of theta. Just solving it. So what did I do here? Let me expand this step. Oh my god. Sine theta is equal to tan over tan theta, which means sine theta divided by tan theta. And our tan theta is equal to sine theta over cos theta. We know this. This is simple formulas. Then we can't divide, so we flip it. And our sine theta cancels with sine theta. We're left with cos theta only. So that's our common ratio. And to find the sum of infinity, we know that the formula is A is equal to 1 minus our common ratio. So keeping that in mind, we write the values. Tan theta is equal to 1 minus cos theta. Done. Khalas. This is it. Yeah, this is it. Next, You can expand tan theta. I think so. You could. Let me check the marking scheme. I think we can expand tan theta. Yes, perfectly fine. You could also expand tan theta, but this is also fine. So that's it. Moving to the next part. Now we are given the value of theta. We are supposed to find the sum of the first 10 terms in the geometric progression. So first we have to find our value of r, which is cos theta. So putting 1 over 3 pi, which means, I think so, 60 degrees. 1 over 3 pi is equal to 60 degrees. Yes, 1 over 3 pi is 60 degrees. You could convert the radians into degrees, but actually you have to keep the answer and everything in radians. So I think it's not a good thing to do that, but okay. R is equal to cos theta. So taking 1 over 3 pi in the calculator, we get 0.5, which is also equal to 1 over 2. Since our value of r is lesser than 1 and it is greater than minus 1, so we're going to use the formula. A is equal to 1 minus Rn into 1 minus r. So why are we using this formula? Why are we not using this formula? We have another formula for this. Why are we not using this? Why? Actually, r is lesser than 1. So if you're doing a subtraction with 1, r should be greater than 1. But r is lesser than 1, so we are putting it afterwards. That's just my trick. I understand that if r is lesser than 1, we put the r after 1. And if it's r is greater than 1, we put it before 1. It's up to you. You could remember it any way you want. So taking it as 10, we have the values of a, we have the value of r, we have the value of n. Substituting it, and they have given that it should be in 3 significant figures. So this is the answer in 3 significant figures. Question number 6. Now we have given a curve. We have to find the minimum point. We have to. Okay, this is a long question. We have 4 marks and quite a long space. So first of all, we are supposed to find the coordinates of point A and point B. Well, the minimum point. What do we do? Well, at the minimum point, our derivative is always equal to 0. Okay? It's always 0. Okay? Because, like, let me show you why 0. Let's say this is my graph. Okay? It's possible that this is not the graph of the equation, but let's just say this is the graph. So this is the minimum point. What is the gradient? To find the gradient, we draw a tangent to find the gradient at this point. Well, this is my tangent. What would be the final answer? This is the tangent. What is the value of y? Y is constant. My x values would change. Okay? My x value would change. But for the gradient to be is equal to y minus y. But my y is constant. 0 divided by 6. So whatever value my x would get after minusing it, our top value would always be 0 because my y is constant. Because on this whole line, the value of y is going to remain same. It's going to be a complete horizontal line. I know my line is not so much horizontal, but it's okay. So if I divide anything here, anything, let's write 6, let's write 20, let's write 23, our answer would always be 0. That means the gradient at the point where my curve is minimum or maximum would always be 0. That's why the derivative at the minimum or maximum point is 0. There's also a point of inflection, by the way, but that's not discussed here. Okay, so now we have to find the derivative. Derivative simple. We have a power of 1. We have a power of 1 here. So subtract it with minus 1 and multiply with the power, we're left with 2. Similarly, 1 over 2 minus 1, we get negative 0.5, and multiply 1 over 2 with 8, we get 1 over 4. So quite simple and understanding. So 0 is equal to our derivative. Solving it, we get the value of x as 4. That is the x coordinates for a point A. Substitute in the equation, y is equal to 2x and minus 8 over x, which for 1 over 2, we get the value of y as minus 8. We have found the coordinates of point A, which is the minimum point. Moving forward, we have to find the coordinates of x and y for point B as well. It is given that the curve intersects at the positive x-axis, meaning that the value of x-axis is intersecting y0. Substitute in the equation and solve it. Well, this is a little tricky to solve it. Okay, at this point, I take x2 common, I simplify it. Well, now we know how to deal with quadratic equations. But do we know how to deal with these equations? Yes, we do. We do a lot of letting, okay? We let that our square root of x is y, replacing this with y and x with y square, we solve it in terms of y. And at the final answer, we replace y with square root of x, and we get the values. And why is 0 not considered? Well, guys, 0 is neither positive nor negative, but it was clearly stated that our b is on the positive x-axis. That's why we are writing b is equal to 16, comma 0. Okay, so I was explaining this question. Well, in this question, this is the continuation. It continued. Yes, this question is continued from the previous question. So in this question, we have to find okay. We are given a diagram and a curve, and also a line, AB. Okay, great. We are given a line. Okay, so we have to find the area that is shaded between the curve and the line. So first of all, we find the whole area, ignoring the line. We just draw another graph. Okay, so let me say something like this. Okay, I know my drawing is not perfect, but it's perfectly fine. So let's say this is my point A, this is my point B. So first of all, we find the whole area between point A and B. The whole area, okay? All the area. And then we draw another line. We draw a line AB. Okay? And then we find the whole area that AB covers. Okay? The whole area that AB covers. Then, if you see, like if I take, let me color it for you guys. Like if I say that I could, first of all, let me find the whole area between A and B for my graph. Let's take orange lines. Whole area. Let's draw lines here. And then let's draw another color of lines. Let's say green for my, no, let's say yellow for my line. If I find the area for the line between these points, it's going to be this. Okay? Okay. So you see that these points, the yellow and the orange lines, are intersecting at this point, but they are not intersecting at the bottom point. Meaning that if I do subtract these values from each other because they're overlapping and I don't need them, I would be left with the final answer that would be the shaded area between this curve and line. So that means we have to find the area of the line and the curve. Find the area of the curve, we need integration. Okay, integration. Simple. Integration is quite simple and understanding if you understand the concept. So we have the upper bounds and the lower bounds because we are talking about the x-axis, point A and B. We have to find the area between these 2 points. So the x-axis are 4 and 16. We find upper bound, lower bound. Upper is greater, lower is smaller. Upper bound 16, lower bound 4. Put the equation of the curve, integrated. So in integration, we add in the power. So the power is 1, we add 1, we get 2. And we also divide with the power because integration is the opposite of derivative. In derivative, we subtract from the power and we multiply the power. While integration, we add in the power and divide with the power. That's the rule. So we do that. We write the upper bounds and lower bounds. Now we simplify it. So what did I do here to get this answer? So what did I do? Let me tell you. Well, what is the purpose of the upper bounds and the lower bounds? Well, we substitute the value of 16, okay, in the equation that we have after derivative and integration and everything. We get the final answer like this part. We solve it. Similarly, we do for 4. We solve this part as well. And then we subtract this one from this one. And that's how we get the area between points A and B for the curve. This is not our final answer. We still need to find the area between the line. So we get the line. We solve it. Okay, so I took 1/3 common because it's constant, and the integration of constants, we could just keep it at the side. So taking 1 over 3 common, we are left with 2x minus 32. For 2x, we integrated to x squared with 32, which becomes minus 32, simple. And then we just put the value of 16 and 4. Simplify it by subtracting, just like I told you, upper and lower bound subtract after applying them, and get the final answer for the area between points A and B for the line. Now we subtract 1 over the line area between the curve and the line. To find that, we subtract them. 176 over 3 minus 43, we will left with the area as 33 over 3 units square. Unit square. I think you have to write unit square. Let me just check. Sure, you do have to write unit square. No, it's not compulsory for you to write unit square. Okay, now we're done. Moving forward. Question number 7. The equation of a circle is given and a line is given. Oh, I hate this question already. Okay, find the two possible values of constant A. So we have a constant A, and this A is actually our center as well. This value of A here is our value of center. This value of A here actually denotes our value of the y-intercept for the line as well. So moving forward. So y is equal to a minus x. We put this value in the equation and replace our y. We get x minus x squared. Okay, this. We solve it, we simplify it, we open the brackets, we everything. We are left with this equation. Okay. So now what are we supposed to do? Well, actually this line, they're saying that is tangent. So what does that mean? Well, actually that means that our discriminant b squared minus 4ac is equal to 0. This is an already said law, so you have to remember it. So it's tangent, so we solve it. We put the values, this is our A. Wait a minute. This is my A, this is my B, and this whole constant thing is my C. Okay, so we solve it. We open the brackets again, we multiply everything. We are now down to this part. So now we again solve it, simplify it. Minus A is equal to 0, or 36A minus 144 is equal to 0. And we are getting with two terms of A is equal to 0 or A is equal to 4. That's it. They said two terms. Or is there any okay, two possible values. That is 0 and 4. A is equal to 0 and 4. Now part B. Why is there a part B? Okay. For the greater value of A, find the equation of the diameter which okay. So actually, when these type of questions come and you have to find what you're doing, I think it's better to draw a diagram like this. So it just gives you a little understanding. What do you need? What do you have and everything. So look, you see, I've drawn a circle. We have a center, we have a tangent, and we have a diameter line. So what they're asking us? They're asking us to find the equation of the diameter that is perpendicular to the tangent. Actually, you could draw the diameter anywhere, that any line that passes through the circle and touches both ends of the circle is our diameter. It could be anywhere. So we have to find a specific line, a very specific line of the diameter that is also perpendicular to our tangent that is already drawn. So we have the equation of the circle. This is the greater value of A. We have A as plus 4. We just substitute it here. Okay? So if I substitute here, my value of the center is minus 4. Oh, so it's, sorry, first the x-axis. 6, comma, minus 4. Well, this thing should have been negative to have it positive here, because y minus 4 is equal to positive 4, and y plus 4 would, if I simplify it, this is 0 then. Okay, this is 0 here as well. Then y would equal to 4. If it's negative, y would equal to 4. But if it's positive, y is equal to negative 4. That's why we are writing the center y coordinates and negative 4. Then we have the equation of the tangent. We have substituted the value in 2a. And our a is 4 because we are using the greater value of a. So we get this equation of tangent. After simplification and everything, now we have to look at this equation quite understandingly. The gradient of the tangent. Okay, so let me see. Y is equal to mx plus c. Okay, so c is constant and we have an 8. So y is equal to, let's try to write both equations side by side. plus 8. Okay? So if I see this equation, my c is 8, my x is given. What is my m? My m would be minus. Minus what? Minus 1. Okay? So that means the gradient of the tangent was minus 1. If my gradient of tangent is minus 1, what is my gradient for the perpendicular line, which is the equation for the diameter? Okay? So actually it is that if the lines are perpendicular, both their gradients, if I multiply them, my final answer should be minus 1. So the gradient of my tangent is minus 1. What is my gradient for the diameter? So it's minus 1. We simplify it, we get the gradient of the diameter as positive 1. Okay? This is also a understanding that we have learned in our book. For parallel lines, the gradient is same. For perpendicular line, it's inverse, negative inverse. So the equation of the diameter would have the gradient of positive 1. Now we are going to solve and find the equation using y is equal to y1 into m is equal to x minus x1. We know that the diameter, wherever it is, it should pass through the center. So we have the points of the center, plus 6 and minus 4. Substituted as y1 and x1 because this is y x1 and this is my beautiful y1. Substituted, our gradient is same. We get a beautiful equation for our diameter and that's it. How many marks did I get for doing this? 3 marks? Okay, 3 marks. This is not worth it. Okay, now next question. This question is quite beautiful. I love these questions. They're like using lots of our brain. So these questions are quite easy if you understand and how you're supposed to do them. So try to label the diagram so you know what you're given and what you're not given and what so. The diameter shows. Okay. So we are given that the radius, that means that BF, AB, CD, or ECE, whatever, is 0.4 centimeter. And we have to show that my line between this point and this point, F and E, is 2.4 centimeter. What do we need and how can we do this? So if I draw a perfectly straight line from here and here that cuts F and E at 2 points, that's perfectly straight, perpendicular this thing. That means that this makes a rectangle. I know mine is not perfect, but it would make a rectangle to 2 centimeter and 2 centimeter. Both sides would be same. But, if I am able to somehow find this part and this part, and then add it, the overall answer should be equal to 2.4. Now, how am I supposed to find these parts? I've labeled them as x and z. So fx and ze or ez are the parts we are supposed to find. So if I try and see, look guys, we see a right triangle here. And whenever we see a right triangle, we know what you're supposed to do. Right triangles, Pythagoras theorem, trigonometric functions, or anything. Okay, whatever. My triangle is not beautiful. Okay, this is 1 over 6 pi. And this is, let me draw a straight line. I don't like this triangle already. Let me draw this triangle so it's beautiful. I need, oh my god, why is this so bad? Let me try right here then. I need a big triangle. Okay, now this is my triangle. This is my right angle. This is my right angle triangle. This is my 1 over 6 pi. This is my 1 over 6 pi. This is the side we're finding. This is my x. This is my f. And this is my 0.4 centimeter. My hypotenuse. Like, look, this is the hypotenuse is 0.4 centimeter. Okay. So this is the thing we're finding. This thing and this. Actually, guys, I have like rotated the triangle so that it's straight and more understanding. Okay. Okay. So now we're going to using this SOHCAHTOA 2A. This is a lovely trick to remember. Sine opposite hypotenuse. Cosine adjacent hypotenuse. Tangent opposite over adjacent. So which do we use? We need to find this side. This is the opposite side. So that means this one is cancelling. We are going to use this one or this one. Now we see. We have the hypotenuse. So we're going to use, this is also cancelled. This is the final answer. We're going to be using the sine operation. Sine is equal to opposite over hypotenuse. Okay? So what is my opposite? Opposite is my value we're finding. Let me write it here. Sine theta is my opposite, which is f of x, over my value of hypotenuse, which is 0.4. Taking 0.4 there, f of x is equal to sine theta into 0.4. That's exactly what I did here. BC is 2 centimeter because it's a rectangle. And we're going to multiply by 2 because f of x and z of e are equal. Because it's symmetrical. Okay? So sine theta is equal to 0 into 0.4 is my value. So we're replacing theta with 1 over 6 pi. Because this is the angle for our triangle we are using. So EF is equal to 2.4. Hence proved. And 2 marks we have gained officially. Moving forward. Find the area of the plate. Okay, this is a long question. Okay, so find the area of the plate. We have to see the image again. Okay, let me just erase the extra writing we have because I want the image to be completely plain so that we can understand more. Okay, so this is the equation. So you see, to find the area of this lovely symmetrical image ABCDEF, we need to find the area of the sectors because we can't find the area of this thing separately. We can't do that. Or maybe you can, but I'm not doing that. Because I'm going to split it into parts. I have one sector, one triangle, one rectangle, another triangle, and another sector. Sectors are same, the triangles are same. That means that if I could find the area of one triangle, I could just multiply by 2 to find the area of both triangles. So it's symmetrical, so we are going to split it into parts. 2 into the area of sector, 2 times the area of a triangle, and the area of a rectangle. First, we're going to find the area of our sectors. Okay? To find the area of sectors, we are going to use the formula 2 is equal to 1 over 2 r squared theta. We have the values of theta, we have the values of r. We find the area as this. Okay? This is calculated things. You can do it. I'm just explaining how we're doing it. Okay? The steps. Now we have to find the area of the triangles, which is equal to 1 over 2 base into height multiplied by 2 because we have 2 triangles. So we have to find the base, we have to find the height. To find the base, we use again so 2r. Okay? Draw the triangle, find the values. That's easy. Okay? I hope it's easy. If it's not easy, let me know. I would explain these parts in my next videos. Okay? But I think it's easy. You could understand this part. Then we find the area of the rectangle, base into height. Everybody knows, length to the breadth, whatever you use. Find it, and the overall area would be the addition of all of them. And we have officially found the area as this. But, they said it should be in 3 significant figures. This is 4 significant figures, guys. What do? We round it off. We are left with 0.3. Why am I writing under 0? Because it has 3 significant zeros, 3 significant figures, and zeros at the end of my numerical digit or on the right side of my decimal are significant. Zeros after significant digits are significant. Okay, this is a law. It could be considered significant. Okay, so it is given that the parameter of the plate is this, and now we have to find the radius. How many marks? 4 marks. Okay, so now again we need to understand how we are finding the parameters. So if I'm a human, let's draw a human at point A. So what is a parameter? We walk from point A, B, C, D, E, F, and back to point A. This is the parameter. Walking around a figure. So what do I need to find the parameter? I need the length of AB, I need the length of BC, CD, DE, EF, and AB. Well, now we know. We need to find the length of AB and CD, which is the radius already. That means 2 radius into 2 centimeter into my arc length into again 2 centimeters and my value of this, which is going to change because it is affected by my radius. Okay, it is affected by my radius. So let's go. We have 2 arc lengths plus 2 plus 2. Why 2 plus 2? Well, BC and this XZ is 2 plus 2. Then we have 2R, just as explained, CD and AB. Then we have 2 arc lengths, and then we have 2R into sine 1 over 6 pi. Well, guys, this is explained already how I get R. Okay, let me just explain how we get r here, okay? How we get this. I think you did understand how we got fx using this formula. It's not that much difficult. You could do it. If you don't, let me know. I would help you guys. Okay? So the arc length, we have a formula, r theta. We have two arc lengths. We have on one side, another side. 2 plus 2, 4. Simplify it. Quite simple. Make it as small as you can. And we're left with this. Then we can easily divide it because it's in 3 significant figures. We get this as final answer. That's it. Next question. Question number 9. Okay, so this question is f dash of x. Okay, this dash, beautiful dash that's labeled here, this is for derivative. It means derivation, okay? It means dy or dx. And it's saying that determine the values of x for which my function is decreasing. So if my function is decreasing, it means that whatever my derivative is, it should also be lesser than 0. So we are already given the derivative, okay? This is not the function, this is the derivative. F is the function, f dash of x is the derivative. So putting the derivative, putting it lesser than 0, okay? So it's lesser than 0. Let's just move these signs and replace it with equal to because it's more simple and understanding for all of us. Using equal to, and then we are left with this. We find the values of x, simplifying, splitting term and everything. We get two values of x. Now we put the symbols back. Well, if I see my equation that I made right over here, well, I could tell that it's a minimum function. That means that my graph is going to be a smiley face, not a sad face, because my value of a, this is my a, this is my b, this is my c. When my value of a, if it's greater than 0, then our answer, or whatever my graph would be, it's going to be a smiley face, meaning that it has a minimum point. The smiley face being drawn, writing the values on the number line. Let's see which part is lesser than 0. This part, meaning that if I have a value that is lesser than 9/4 and greater than 1, my value for the function would be decreasing. Okay, that's the final answer. Okay, so next question. Given that f1 is equal to minus, okay, so what are we given? Let me just explain this part first. What are we given? f1 is equal to minus. What does this mean? Okay, guys, this is the value of our y-axis, meaning our output. This is our value of input, meaning the x value. Okay, so that means my 1 is equal to x, and if my x is equal to 1, my value for y should be equal to minus. But, we don't have f of x, and we have to find it. Well, that's where integration steps in. So we have the derivative. We integrate it. Well, integration is the inverse of derivation. So I'm going to open this bracket. You can do it without opening the bracket by using chain rule, prior rule, whatever. But I think it's good to open it. I know it would increase the steps. I know it would make it a little long, but there's less chances of errors when I do this. I find this method better. You could use a chain rule. You could use any rule you want. Okay, it's up to you. Totally up to you. So I'm opening it and I am now having single terms with x and constants, okay? Now to find the derivative of these terms, it's very easy. It has a power of 2 plus 1 divided by the power of 3 and 3. Similarly, 1 is the power, we add 2, we divide by 2. We have no power, meaning that x power is 0. We add 1 in here, we are left with x and plus c. What is my c? What is the c? Well, c is a constant. And why are we writing a constant? Look, guys, look. Why are we writing c? If I have an equation, let's say y is equal to 5x plus 9. What's my derivative? My derivative dy over dx is only 5, okay? But if I have similar term, y is equal to 20x plus 9. No, wait a minute. Y is equal to, not 20x, let me see. I just want to explain why we're writing c. Y is equal to 5x plus 100. What's my derivative again? It's 5. So that means there's a constant term, there's possibility there's a constant term, but we do not know, and it can take any value. It could be 100, we'll still get the derivative 5. It could have been 9, and we still get the derivative 5. Quite confusing, okay? But there's a constant term when we are using derivative. It's possible, okay? That's why we're writing a plus c with our integrated final answer. So we get a y is equal to x. Now, we get this lovely equation and we have a c, which is a variable, and we still need to find it because we're not done. We needed the whole equation. So now this is where f1 is equal to -1 steps in. As I told you that this 1 is x and this -1 is y. So we substitute the values in our equation because we can find c using this, doing all the math algebra things, and we get the value of c is -24. That's it. Substitute it and we get the equation for our f of x. Okay, that's it for last. Now we have question number 10. Why are there so many curves and derivations? Okay, so this question is again a good question. An equation of the curve is this, and x squared. Okay. So they're saying that a point P is moving along the curve in such a way that my y coordinates of P are decreasing 5 units per second. What does that mean? Okay, let me tell you what it is. That means that dy over dt is my time. That, look, if you remember physics. Okay, what is physics? Speed is equal to distance over time. Okay, speed is equal to distance over time. So we know that my speed at which my y-axis is decreasing is -5 units per second. Okay, so why it's a -5 sign? Because it's decreasing. Decreasing means negative. Negative means decreasing. Okay, both things. We have to find the coordinates of x, and we have to find at what rate, meaning at what speed, my x coordinates are increasing when my value of y was 32. A beautiful question. Okay, so now we have dy over dt, which means dy over dt is -5. So if I find dy over dx, I could arrange the equation such that I could find dx over dt, meaning the speed of the x coordinates. Okay, so we have the value equation for y, this beautiful equation. We derivate this equation using derivation. +5 just goes because the derivative of constant is 0. Okay, so we solve this. 3 over 2 minus 1 is equal to 1 over 2. Multiply with the power, we get this lovely equation for the derivative. Okay, and what do I do now? Look, it's given that if y is equal to 32, finding the value of x. What was the value of x when y was 32? Well, my x was -2. If I put it in the equation and solve it, x is -2. Now we are going to simplify the derivative. We find what was the value of the derivative when y was 32. So we get the value as -9. Because at y is 32, x is equal to -2, we put the value of -2 here, and we get the value of y, dy over dx as -9. Well, what did I do here? Okay, let me explain it, guys. Okay, look. Dy over dx is equal to dy over dt into dt over dx. What does this mean? Well, it means the speed of the y-axis versus the reciprocal of the speed of the x-axis is equal to my derivative. Okay, guys? So now I'm going to just arrange the equation that I just wrote and such that I have the terms dx over dt. So if I multiply dy over dt with the inverse of my gradient that I just found, like if I cancel this part and this part, we are left with dx over dt, and that is what we are finding. Means -5 multiplied by 1 over -9, we get the speed of the x coordinate, which is increasing as 5 over 9 units per second. This is how we do this. I know this question is a little tricky, but fine. Why is there a part B, and why is it 6 marks long? Okay. I think this is the last question, by the way. Let's see it. So a point is on the curve that has a coordinates of y as 32. And there's also a point B on the curve that has a gradient as -3. Find a perpendicular bisector of A. I don't want to do this question, okay? But let's just do this question. Okay, so in the previous question, we found that x is equal to -2 when my y was 32. So just writing that as it is. Point A's coordinates are -2 and 32. Now we have to find the coordinates of point B. So that means my derivative is -3. We just found the derivative in the above part as well as this. We just write that here as well. We simplify this derivative, doing the cutting and everything. We get the value of x as 2. Okay, x is 2. So when my x is 2, we could find the value by substituting it into the overall equation as y is equal to 6. And we get the coordinates of point P. Now, what do we need? We need the equation of the perpendicular bisector. And to find the equation of the perpendicular bisector of between 2 points, we need the midpoint, we need the gradient, and we need point A's and B's. Oh, sorry, point X and Y. Well, the points X and Y are usually the midpoints that we make. Okay, so finding the midpoint, we put the value of, let me show you how we find the midpoint. So we have point A as -2 and 32. We have point B as 2, 6. Well, the midpoint between two things is X values both subtracted divided by 2. X1, okay, and similarly Y1 minus 22 all over 2. This is my midpoint, okay? So we found the midpoint using this lovely formula. I don't think this formula is in MF19, okay? But it's an easy formula, you can remember it. Okay, so we found the midpoint as 0, 19. Now what is the gradient of the line? We have points A and B. The line is a straight line, so we can find the gradient using y2 minus y1 over x2 minus x1. So we found the gradient as -13 over 2. What is the gradient of the perpendicular bisector? As I told you just in the previous 1 or 2 questions above, I told you that if this is my line and this is another line, whatever the gradient is of this line, it is the negative reciprocal of the above line. So M2 should be equal to -1. Okay, why is my 1 so bad? -1, okay? So if I have two lines that are perpendicular to each other, and if I multiply their gradients with each other, whatever my answer is, it should be -1, okay? So that is the reason I could easily find my gradient for my perpendicular bisector as well, because -13 over 2 multiplied by my gradient of the perpendicular 6M2 is equal to -1. Taking to the other side, my M2 would be equal to 2 over 13. That's it. That's my gradient of the perpendicular bisector. Now we have the points X and Y as well that we can use because it's a midpoint. That's where my equation of the line is starting for the perpendicular bisector of AB. We have the gradient, we have all the terms. Just substitute them in this equation. Okay, what are we using? We are using 0, 19 as x1 and y1. Okay, that's it. Then substitute them, solve them, and we write the final answer as this because it was clearly stated that give your answer in ax plus by plus c. So I think it's good to arrange the terms as your final answer in the same sequence, x, then y, then constant. And guys, that's it. This paper is done. And I think it is better to just explain the paper. So I have attached the solved solution of this paper in the description if you want. And that's it for this paper. I will be back with another video with paper 1-3 next time. Till then, bye-bye.